welcome to the channel. Today we're doing problem 2, add two numbers. This problem was given by Tesla in a coding interview. Now, we already did this in C#, and today we're going to be doing it in JavaScript as per usual. So let's start by reading the problem, and then I'm going to be explaining it and finally coding it in JS. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of the nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zeros except the number 0 itself. And here we have one example. I usually like these examples to go through them because they show the solution pretty well. So I'm gonna start by saying that these are going to be list 1 and list 2. And we're going to be beginning by actually having a reference to the first node, and we also call this the head node in both of the lists. Now, when we actually start, one thing that's interesting is that in our world, when we calculate 22 plus 8, I do see that this here is going to be 10. I'm going to be placing 0, and I'm actually going to take 1 and move it to the left side. So the only thing that's going to be a bit more complicated to think about and to wrap your head around is that when we actually take 1, we're not going to be leaving it to the left, we're going to be leading it to the right, because the next node in the list is the one on the right, not the one on the left. So, just to keep this in mind. Now I'm going to Control Z a couple of times here just to remove these, and we're going to be continuing with the example. So let's say that L1 value and L2 value match up and they give us 7. Then we have 4 and 6, which is going to be giving us 10. Now here's the interesting part. I will be placing 0 here, and I will be having 1 into consideration. So this is going to be my carry. And now when both of these, they were here, both of these move to the final node of the list, I'm going to calculate that this is going to be 7. And with the 1 that I had, the carry, I am actually going to have 8. So I'm just going to be pushing it over here. One more thing to notice before we actually begin is that if I have L1 being a reference to, let's say, a starting linked list, and L2, say, equal to L1, this internally means that L2 is just going to be pointing at this node. Now, what's interesting is that if I actually take L1 and I move it a couple of times into my iteration, and let's say that I have 1, 1, 1, and I want to make each and every single list value here 0. Now I'm going to go here with L1, I'm going to be making it 0, I'm going to go here, make it 0, I'm going to go here, make it 0, and now everything has the value 0. But if I decide to iterate through the list with using L1 reference, it's already pointing to nothing. That's how we understand that we're actually at the end. And that is why we are creating a new variable here to store the reference. We call this head and we call this tail. So we always want to point at the head with 2 parameters, because the first one during the iteration is going to be no, and then we're just going to be returning the second one, which is basically going to do the same thing because it's going to start from the beginning and then we're going to get the right results. All right. Now, Control-Alt-D to remove my drawing skills, and let's actually code it up and see what we have. So this is going to be JavaScript, meaning that we want to truncate after we do the division, because we're going to get interesting results, but this is not a problem. You're going to see how I do it. All right, let's actually declare variables that we are using, or we're about to use. This is going to be the first carry. So sorry for this, I just continue doing it because I leave my tablet over here. Let me just zoom in once. All right, so let's say that I'm going to have carry that's going to be equal to 0, and probably I should zoom again, not so much. I think this is okay. I'm going to be putting it on the left. All right, so carry is going to be 0. Then I need to have 2 elements that I'm going to be extracting with the references. So I'm going to say let x equal 0, and I'm going to say y is going to be 0 again. And the final thing is the total sum that I will be using to actually create the new linked list, and I'm going to be placing the total sum over there because 2, 5, and then the total sum among these two. And we can of course do it with 3 list nodes, with 4, it doesn't really matter. All right, so total sum. Now these here are the ones that we're going to be using for calc. And here are the ones that we're going to be using. So the C variables that we are using for iterations. All right, so these are going to be output list. That's going to be equal to new list node of 0. One thing to keep in mind is that whenever I start something, and now let me just go to drawing here. When I start, I do not want to say L1 and then actually having something like, let's say, the first value. Actually, you need to create the first value because after that it's going to be a bit more complicated because you're going to make L1 equal to the new list node of total sum. And at the beginning, you're going to have this total sum, and then you're just going to start moving forward. What I want to have is L1 pointing at something like something that I can skip over, and then each and every one of the others are going to be the total sum of both of the lists. And when I return, I'm just going to return not the first element, rather the second, because this is going to be the beginning. All right, so this is something to keep in mind. That's why I'm going to be creating the output list as a new list node of 0 here. This is going to be skipped over. All right, final output is going to be equal to output list. This here is the second reference that we have to output list. If you remember when I was talking 2 minutes ago about having 2 references pointing to the head, because the first reference, the first head is going to be ending up at the tail, and then we want to move from the head again. So this is going to be, and actually I can do L1 here and L2, just so you can see what I was trying to explain. And then we're just going to say first list is going to be L1, and that first list is going to be equal to, sorry about the noise, L2. All right, we understood. Here it's not going to be first list, it's going to be second list. All right, good. So now we need to be taking over the iteration, and I'm going to say, well, first list is not equal to no, or second list is not equal to no. Now, keep in mind that even if I end up at the no state, I still should continue, and I'm going to show why, even though it's probably easy and you already figured it out because you're smart, but I'm going to show you nonetheless. So let's say that I have 2 and 4 as nodes, and then I have 3. So if I stop, if some of the nodes gets to no, and this is how we're saying that we're over the list. So let me just write it down real quick. Let's say that I have 5 over here, and this one is no, and instead of appending 4, so having 54, I'm just going to return the number 5. And this is obviously a problem. It's not the correct solution. So that is why we're saying or here, and we're not saying and. Okay, so let me just continue now. Good. Now, I do want to extract the value. I'm going to do it the following way. If first list is not equal to no, and here I need to do the check, because even if one of them is no, I'm not going to break the loop, meaning that one of them will possibly be no. That's why I need to check before extracting the value. First list is not equal to no, then I'm just going to extract first list.value. Otherwise, I'm going to be placing 0 because I'm not going to mess up the calculations. Y is going to be equal to second list, not equal to no. Then I'm going to extract second list.value. Otherwise, I'm going to be placing 0. Okay, good. Now we need to figure out the total sum. This is actually the easy part. I'm just going to say total sum equals to x plus y plus carry. At the first time, we're just going to have a carry of 0. So this is just going to give me, let's say, the number 12. Then I'm going to be extracting that, and I'm going to be placing 2 as a carry, and I'm going to be placing 1 in the node. And I'm going to remove this comment so you just don't mistake it for something valid, because it's just a made-up artificial number here, just to show you what I mean. Then I'm just going to create the carry. Now I need to divide by 10 and let's say 12. I need to find a carry of 12. Obviously, I'm just going to divide by 10, and I'm gonna extract 2. So this is going to be math.trunc because I want to truncate the number, and I'm gonna say sum, total sum divided by 10. All right, the final part is me appending the new value that I have into a list node. Now, if I have 10, I do not want to append, or if I have 12, I do not want to append 12, of course. I'm just going to divide this by 10, and 2 is going to go into the carry. And then I'm actually going to have 1 here, but if there is something bigger, I need to say modulus 10 in order for me to get the value. So this is done with saying output list.next is going to be equal to a new list node of our total sum modulus 10. This is going to achieve the fact me not placing 20 or something like that. Always put the numbers in a border from 0 to 9. All right. So output list then is going to be equal to output list.next. This is me moving to the second point, and in the beginning I'm just going to move to a no reference place, and then I'm just going to create it over here. Since this is going to be output list.next, the next value is going to be valid. I'm just going to move to it and then move to it and move to it as long as I finish the first list and the second list, both of them. All right. Now the final part is that when we actually moved these, when we actually calculated, we want to move one step ahead into the list 1 and to the list 2. Keep in mind, once again, that we can have a null variable here. So that's why before moving, I want to check. And the way I'm going to do it is I'm going to check if first list is not equal to no. Then I'm just going to say first list is going to be equal to first list.next. That's how I'm going to move. The same is going to go for second list. Second list is equal to second list.next. And this should be good to go now. All right, we are going to be exiting the while loop. And one thing very important to note is that we might have a carry over here that we have not yet considered because we have ended up to the loop. So here, if we have 6 plus 4, which is going to end, both of them are going to be, both of list 1 and list 2 can be no. And I'm going to append 0, but then I need to append the 1. So I'm just going to say an extra check here. If carry is bigger than 0, I am just going to say output list next is going to be equal to a new list node of the carry. So if carry is 2, I'm just going to append it to the end. And of course, we're just going to return final output dot next. Now I will be appending final output dot next because the first list node is actually going to be consisted of 0, which is the artificial number that we have created it, and this is going to mess up the things. So that's why I'm just going to be returning point next. All right, let's run it and hopefully, all right, submit. And let's see if it's going to run faster than C#. Oh, wow, impressive, even though these numbers do not matter.